Ladies and gentlemen, on behalf of the Royal Society of Victoria, I'm delighted to welcome you to this evening's discussion, Earthrise. My name is David Zerman, and I have the pleasure of being the 71st President of the Royal Society of Victoria, which was established, as it says here. We've been promoting science since 1854 and promoting solar science since 1874. And despite what most people think, I wasn't at the original meeting. I'd like to acknowledge the traditional owners of the land on which we are meeting, the people of the Kulin Nation, and I wish to acknowledge them, their elders past and present, and any Indigenous Australians who have joined us here this evening. A warm Womanjika to you all. The Earthrise panel. Tonight we are exceptionally honoured to be presenting this dynamic interdisciplinary panel discussing the social, political, environmental and existential impact of the iconic Earthrise image which was taken in 1968 by the Apollo 8 mission, which was the first manned mission to leave Earth's orbit to circle the moon. I'll leave it to this evening's Emcee, the exceptional Alicia Sometimes, to introduce our distinguished panel. And before I hand over to Alicia, I have a few formal announcements. But before even that, I'd like to publicly thank Paul and Simon from Scientel for their help in making this evening happen. Guys, where are you? There and somewhere there. And many others as well. Thank you to everyone who's helped this come to fruition. One of the best things I have, one of the perks of the job of being, because the salary is so spectacular, you have to understand the salary is truly exceptional. One of the wonderful things I have is welcoming new members, and I'd like to invite Jacinta Kong, who I think is with us. Yes, Jacinta, please come down. Jacinta, one of the great things about joining the Royal Society, besides being able to shake hands with me, I realise that's a great incentive, is to sign the membership book. The membership book goes back to our first days in 1854. It includes all the people who have been members of the Royal Society of Victoria, and their contribution in science and other areas. That is the history of Melbourne in so many ways. I'll invite Mike to take you over to sign the membership register. And yes, we hope it works. A couple of people asked me downstairs, so what do you have to do to be a member of the Royal Society of Victoria? I said, it is exceptionally complex. Fill out the membership form and give us your money, okay? That's all you have to do. But people said to me, but I'm not a scientist. And I said, so what? Are you interested in science? Yes, that's why I'm here. Jacinta, congratulations. Welcome. So if anyone is interested in becoming a member of the Society, we're more than delighted to welcome you. Now for tonight's presentation. As Alicia will be introducing our panellists, I'll be introducing Alicia. But I just want to talk a little bit about, exceptionally for 2 minutes, about how I became interested in science. On the 5th or 6th of October 1957, before I was really born, when I was not quite 7 years old, so you can work out that I've just turned 68, I was taken to the backyard of our house in Pascoe Vale South, 111 Melville Road, Pascoe Vale South, where my late father had his surgery. And there were many families, not only in our backyards, but sharing the backyards of others, looking up in the sky for Sputnik as it went overhead. And that was a big thing in 1957. I won't ask who else had a look at it at that stage. I don't want anyone to admit their age. And that really was my first interest in science. People say to me, oh, I suppose you're a scientist, you do that. I said, no, I'm just interested in science. And that's why I think events such as this and a multidisciplinary panel will be able to give us such an insight into another aspect of the knowledge and beauty of science. So let's come to the Emcee with the mostest. Alicia Sometimes is known. I hadn't met Alicia until this evening, but hey, I've been a fan of hers on 774 for many years, and my first words were, I always wondered what radio people look like when I see them for the first time. And she said, did you think I was blonde and whatever? I said, I had no idea. I said, I'm just interested, if there's a correlation between the voice and how someone looks. As a broadcaster, poet and writer, Alicia contributes to the Outer Sanctum podcast, and her powers have been featured in Best Australian Poems, Overland, Southerly, Westerly, The Age and more. She was editor of the National Literary Journal Going Down Swinging for 7 years and one of 3RRR's breakfast team in 2015 and appeared on oral text for 14 years. Before I formally invite Alicia to introduce the panellists, Alicia, would you like to come over here so I can ask you a few questions? Because that's another prerogative that I have, shaking people's hands and asking MCs or speakers questions. So how did you develop your interest in science?
I was in love with Carl Sagan. I was very young, and my mum and dad would have lots of soirees and parties, and when they did, they would put on either Monty Python or I remember sitting in front of Carl Sagan's Cosmos series, and I just loved the lilt in his voice, his big lapels, and also the fact that he happened to talk about the beauty of the universe. So that's what got me interested in science.
Did you have any teachers who encouraged you to go into science?
Quite the opposite. And I thought that science was all about biology, and we dissected chickens. And as a vegetarian from a very young age, this put me off science for quite a while. And my teachers told me to stick with the arts and not be a scientist.
So how do you feel that you've married your love of the arts with your love of science?
I can't help myself. So it's one of those things when you're passionate about something, I love learning about new things. There's always books by the side of my bed that are on science, so I love to marry astrophysics and art or quantum physics and art. I just think that the two are beautiful and boundless, and there's so much that you can do. There's never a time when I want to stop.
Thank you very much. Ladies and gentlemen, I'll hand over to Alicia in a moment, but I'd also like to introduce Kevin Allman Rossiter. No, that's okay, don't go away. Who will be handling the rest of the meeting at the end from this podium. And I'm going to sit up the back and enjoy it just as much as you are. Alicia, thank you very much indeed, and thank you for being the MC for this evening. Thank you.
Thanks, David. And thank you to the Royal Society of Victoria, and thank you for all coming. What an amazing panel of people talking tonight. And welcome to Earthrise, looking back on our planet. To the moon and back. We have always pondered the moonscape. We have looked up at the night sky and longed for it, sang to it, written about it, drawn it, woven it into the fabric of who we are and who we want to be. So many poems and odes have celebrated its place in the universe, in our universe. Shelley asked the moon, "Art thou pale for weariness of climbing heaven and gazing the earth?" He was saying something humans had thought often, but not quite articulated so simply, that the moon must stare back at us. We mostly thought in terms of what the moon looks like from Earth. The moon dwindled and thinned to the fringe of a fingernail held to a candle. That was Gerard Manley Hopkins' poem called Moonrise. And in 1968, almost 50 years exactly, we got the first glimpse of a fragile blue sphere set in deep dark space peeking over the moon. It was an Earthrise. Apollo 8, piloted by William Anders and his fellow crewmen Frank Borman and Jim Lovell, knew that this was a pioneering adventure, something so bold and audacious that their trip was always destined to be etched in history, but it could have turned out so many different ways. After the tragedy of Apollo 1 and the very nature of space travel, there was no way to know for sure how this Apollo mission would end. The flight operations director gave its chance of safe return at 50%, and some thought that was too high. In the early stages of flight, with the Earth receding, Lovell noticed how he could put out his thumb and his little finger and mark the span of the Atlantic Ocean. Borman said to Control, "Tell the people in Terra del Fuego to put their raincoats on. It looks like there'll be a storm." And after 68 hours of travelling and some sickness in the cabin, they reached the moon for their lunar orbits. And when their spacecraft came out from behind the moon for its fourth pass, the crew witnessed an Earthrise for the first time in human history. Anders took a black and white shot, then asked Lovell for some colour film, and took the famous photo, later picked by Life magazine as one of its 100 photos of the century. And we must remember the backdrop of 1968. The Vietnam War was escalating, the Cold War still brewing, Martin Luther King Jr. and Robert Kennedy were assassinated. And from the distance, this time seems like an epoch of great upheaval and transformation. And this mission became one of perspective, how billions of human beings coexist on one common ground. Apollo 8's Christmas Eve address captured the mood of hope and wonder. An estimated 1 billion people in 64 countries heard or viewed the live reading and greeting. The three men took turns in reading from the book of Genesis and ended with the words, "And God bless you all of you on the good earth." Lovell also said somewhere in there too, "Please be advised, there is a Santa Claus." Apollo 8 paved the way for the moon landing and advanced space travel. But that photo immediately signified more. It was for humanity. It was about seeing beyond ourselves, beyond borders and lines that we arbitrarily draw up. It was about sharing one space within space, a planet that has a thin sheet of air extending from the surface of the Earth to the edges of space, an atmosphere that counts on all of us working together to protect it. The Earthrise photo has been forgotten by some in recent years because when we think of our vulnerable planet isolated in darkness, we often think of the photo scientist Carl Sagan made famous in his book Pale Blue Dot, a photo taken by Voyager 1 in 1990 that looks back from the fringes of our solar system, 6.4 billion kilometres away from home. Earth is only a tiny point of light in this picture, 0.12 pixels in size, a minuscule blue smudge amongst scattered rays of light emanating from our sun. Sagan begins in his book, "Look again at that dot. That's here, that's home, that's us. On it, everyone you love, everyone you know, everyone you've ever heard of, every human being who ever was, lived out their lives. The aggregate of our joy and suffering, thousands of confident religions, ideologies and economic doctrines, every hunter and forager, every hero and coward, every creator and destroyer of civilization, every king and peasant, every young couple in love, every mother and father, hopeful child, inventor, explorer, every teacher of morals, every corrupt politician, every superstar, every supreme leader, every saint and sinner in the history of our species lived there on a mote of dust suspended in a sunbeam." He ends the passage with, "There is perhaps no better demonstration of the folly of human conceits than this distant image of our tiny world. To me, it underscores our responsibility to deal more kindly with one another and to preserve and cherish the pale blue dot, the only home we've ever known." And Apollo 8 gives us our first personal, stunning view of home. Borman later recalled, It was the most beautiful, heart-catching sight of my life, one that sent a torrent of nostalgia, of sheer homesickness through me. It was the only thing in space that had any colour to it. Everything else was either black or white, but not Earth. We're here tonight to celebrate the Earthrise photo, but it's also a celebration of Earth itself. How have we changed in 50 years? How far have we come? What are we doing to safeguard the planet? We look at many things from climate to ecology to astrophysics to art history. We are so lucky to hear from these four incredible thinkers and change makers. Artist and art historian, Dr. Colleen Boyle, CEO of Zoos Victoria and the President of the World Association of Zoos and Aquariums, Dr. Jenny Gray, Head of Astrophysics at the University Melbourne School of Physics, Professor Rachel Webster, and Senior Climatologist with the Bureau of Meteorology, Dr. Lynette Bettio. And here, up first to talk about the Earthrise photo is Dr. Professor Rachel Webster. And before we give her a round of applause and everyone else, I wanted to say that Professor Rachel Webster, Head of Astrophysics at the University of Melbourne School of Physics, she heads a research group at the University of Melbourne comprising of more than 60 research students and staff. The observational program utilises world-class equipment such as the Australia Telescope Compact Array, the Gemini telescopes, the Hubble Space Telescope, and the Chandra X-ray Observatory, among others. Her research interests include the detection of the first sources in the universe, quasar emission regions, gravitational lensing, and cosmology, with a side interest in the physics of geothermal energy. What are you guys doing with your time? Because I don't know. I want you to give Rachel a big round of applause.
Well, thank you very much, Alicia. That was a very generous welcome, and it's a great pleasure to be here this evening. And, you know, what an extraordinary photograph. We're seeing for the first time the Earth viewed across a barren moonscape, and how evocative is that? So I'm the astrophysicist here, so I'm going to take you back to 1968, and the first image I want to show is something called the Hubble Ultra Deep Field. And this image is in size, it's 1/10 of the diameter of the moon, and within that image, every little speck of light there, or actually bar one, is a galaxy. And there are about 10,000 galaxies in that image. And when the Earthrise picture was taken, 1968, we didn't even really know that this sort of universe existed. We hadn't yet come to the conclusion that the Big Bang Theory was the right way to describe the universe. There was still a lot of contention about, you know, what was out there beyond our own galaxy. So you see here, quite an extraordinary vision of how huge, how vast the universe is. The second image is, of course, of the Milky Way. And you can see it here stretched out across the sky. There are two other little galaxies here. Those are the Large and Small Magellanic Clouds. And those, of course, are some of the sorts of galaxies that we see in the second image here. And what when I looked at the Earthrise picture, I thought there are words that immediately spring to mind, as far as I'm concerned, that describe what I'm feeling. And so the first one, the Hubble one, is about vastness, just the vastness of the scale of the universe. And behind the Earth, we just see black, but in that darkness are all of these galaxies. And then the second one is insignificance. And if we actually look at the number of stars in the Milky Way, there's about 10 to the 11, so that's 100,000 million, it's an awful lot. And our little planet orbits around one of those stars, so we're not terribly important when it comes down to it. And the insignificance continues if we actually look at each of those stars and ask ourselves well, are there other planets around them? Basically, what you're seeing there are some of the more than 3,000 solar systems that have been discovered around other stars in our galaxy. So we're finding them at the rate of tens, per week. So there are many, many other solar systems out there. Our own solar system is just one of a few. And you can see the scale of our solar system, and most of these guys are actually much smaller, so we're only sampling a very few of what's available out there. So the next thing that I think about when I look at the image of the Earth is I think of what it's made of. So it's made of lots of elements. It's made of silicon, it's made of iron, it's made of copper, there's probably even a little bit of gold in there. And so where does all of that come from? And of course, all of those elements are born in supernovae. And this is an image of a supernova remnant, an explosion that happened, probably a reasonable distance away from us. But what we know is that there must have been at least 1 or 2 generations of supernovae in the vicinity of our star, before our star was born, that created all the elements that we see in the universe today. So when it started out, there was hydrogen and helium. So those are the first 2 elements in the periodic table. And now, of course, it stretches out past 100 elements. And all of those heavier elements were formed in an explosion like this. After the explosion, the gases gathered together and eventually formed our sun and our planet. So the supernova gives us the elements. And of course, what the elements give us then is colour. And Alicia already remarked on colour, so this is without any consultation. We're heading on exactly the same themes. But of course, when you look at the Earth, that image, it's the colour that you see, and that colour is generated by the elements that you see, that comprise the Earth. And in this supernova, the colours that you see here are real because each of those elements in its gaseous form shines with a particular signature that has a colour. And so that's how we see it. And then if we go on, this is it's a sort of a slightly busier image, but it's showing a lot of the objects in the solar system. That's our guy there. And you probably recognise this one here. It's Jupiter, there's Saturn and so on. So basically these are all the familiar planets in the solar system. And the lines that you see here are traces representing the spectrum of the light that comes from those planets. Okay? And so the spectrum is telling us about the composition of each of those objects. And what, let's not worry about the details. All that you need to be seeing here is that the trace that you see for the Earth is very different from the trace that you see for any of these other objects. So the home that we have, the planet that we live on, is different from the others. And that's a very critical, it's a very critical thing if we're going to start to talk about why we want to live there. That then brings us to looking closely at our own planet. And I just think this is an extraordinary image. So here's the surface of the Earth, and what it shows is the atmosphere of the Earth, and you can see the moon here. And it's not so obvious from where I am, but I hope you can see that the moon doesn't look round. It's actually quite misshapen at the bottom. And that's because the atmosphere is thicker down here, and so the image is being refracted by the thickness of the atmosphere. And in fact, that image is a new moon. It's not shining from sunlight, it's shining from reflected light of the Earth. So quite an extraordinary image. But what I really want to point out is the thickness of the atmosphere. It's not very thick. And in fact, this is an image that is more often shown, and you can really see that the atmosphere around the Earth is really quite thin. It's only a couple of tens of kilometres thick, if you want to think of it in that way. Or another analogy would be to say if you took an apple, it's about the thickness of the skin on the apple. So it's really a very precious part of the ecology, if you like, of the planet that we live on. I'm going to finish with just one. So that's my word for this, which is fragility. Okay, so we have a very fragile environment. And I'm just going to finish with one last image because I can't help but sort of reflect a little bit more on the atmosphere that we have. And of course, as astronomers, we're going out trying to find life on these planets, because surely when we find life, somewhere on a planet other than Earth. This will be one of, well, it'll be a watershed moment, I think, philosophically, in terms of how we think about ourselves. And what astronomers are doing is going out mostly and looking for an atmosphere around a planet that kind of looks like the one we've got. In other words, it's got oxygen in it. But more recently, we've started to get a little bit more sophisticated, and we've understood that the oxygen in our atmosphere is in a disequilibrium state. In other words, if we didn't have life, there wouldn't be oxygen on the planet. Oxygen disappears pretty quickly chemically because it will react with almost anything. So the only reason we have the free oxygen and the ozone is because life is continually generating it. So, think twice before you chop down that tree in the backyard next time. But what we've got a little bit more sophisticated in recent times, and we've also realised that there's a disequilibrium, for instance, between methane and carbon dioxide. So there may be other signatures of life that we can search for that will tell us that this would be a precursor to the sort of life that is more familiar on Earth. And with that, I will leave you. Thank you.
The trouble is, you want to hear so much more, isn't it? It's just like, here's a glimpse of gorgeousness, and that's all we've got time for, because you could listen to each of these speakers for such a long time. Our next speaker is Dr. Colleen Boyle, artist and art historian with RMIT's School of Design. She's an artist and academic working out of Melbourne, Australia, and her current research interests include theories of perception and representation, history and theory of photography, space exploration and space imaging, philosophical interpretations of imagination, scientific imaging, and theories of scientific observation. In 1977, her grandfather took her to see the matinee screening of Star Wars. The windows of the Yay Town Hall had been darkened with previously used black plastic that was ridden with tiny holes. The result was a galaxy of shining stars, and the film hadn't even started. Thus began Colleen's lifelong fascinations with all things to do with outer space. What a gorgeous poetic start to life. Please join me in welcoming Dr. Colleen Boyle.
Thank you. I was actually just listening to Rachel and thinking that my presentation is lacking in poetry and emotion, because you had all those lovely words in there, which of course are often the words that we think of when we look at this image. So I've titled my presentation Picture This, because as hopefully I can explain to you in this very short presentation, all pictures have a history. They don't actually just pop out of nowhere. They have an evolution. They're artefacts that we make and that we enjoy, that we learn from, and then we make something else. So they have this sort of evolutionary process that goes along with them. They don't just emerge out of somebody's consciousness. That's a complete myth, unfortunately. I wish it was that easy as an artist, but no. So when I was at art school at Monash Uni, I found that I gained more inspiration from going to the astronomy and science sections of the library than the art section. And after a while, I began to think, why am I looking at these images so much? And I decided, okay, they're very beautiful. They have an aesthetic quality. You were talking before about Carl Sagan. What a great poetic way of talking about the universe. That's an aesthetic. It's a particular aesthetic. Science has a particular aesthetic, and astronomy in particular has a very accessible one. It's beautiful, after all. So I used to incorporate a lot of astronomical ideas or images in my printmaking then. But I wanted to know more about these space images, and so I went on to Melbourne Uni and did a master's in art history and theory, and I decided to study the photographic work of NASA in particular, and to study them as cultural artefacts and to find out what was going on there with them. So part of my studies, again, was looking at the historical evolution of something like the Earthrise image. We've actually been looking at things from afar for a very long time. Even before we had balloons or aeroplanes, we still had our imagination. And this amazing woodcut by Jacopo de Barbari in 1500 is a really good example of that. So he'd never actually seen Venice from above, but he could still cast his imagination out far enough to then depict it. That's a very important thing. It's a human quality to be able to cast your imagination out somewhere. Keep that in mind. The next way up was in a balloon. And by 1858, photography was so popular, particularly in Europe. Everybody was doing it. In Paris, in London, you'd walk down the street and there'd be like 6 photography shops. Come on in and have your portrait done. Yep. It was a very slow, laborious process, but it was incredibly popular. It was magic. It was a wonderful scientific process that had become incredibly accessible. So the French photographer, whom you may have heard of before, Nadar, which was not his real name, but it was his sort of stage name, I suppose, he was very determined and very tenacious, and he actually managed to make some daguerreotypes inside a balloon as he floated over Paris. Very clunky, but still again, this is the next evolution, the next step up to the Earthrise image. Planes, of course, aerial photography came next. I forgot to put a slide of that in, but anyway, we've only got 10 minutes. So now we're post-World War II. The Americans have confiscated a whole bunch of V2 rockets. They've confiscated the German scientists, and they've taken them to New Mexico. They've modified the nose cone of the rocket, and they've made it fit a 35mm movie camera. And they've put it in this watertight container as well. They shoot this V2 rocket up into the air. It actually manages to leave the atmosphere, get into outer space, shooting the whole time. It then crashes down, they retrieve the film canister, and voila! We have what is actually the first image of the Earth from space. But it's not the whole Earth, it's just a little tiny section. It took a whole bunch of sections. Next step. It's quite interesting also to think that this image, the Earthrise image that we associate so much with these beautiful poetic ideas about humanity and peace, actually came out of all this military technology. Then, of course, the Americans get this image of the Earth from space, and what do they think? They think, oh my God, what if the Russians can see this too? Right? So, Sputnik, as was mentioned before, has been blipping through the sky. The Americans think, right, we've got to up the ante here. So we have Explorer 6. NASA always did things in series, which takes the first TV footage of the Earth from space. But that's what it looked like, okay? Not particularly impressive. But President Johnson, he goes, okay, without satellites, I'd be acting by guess or by God, but I know exactly how many missiles the enemy has, right? So what's driving this stuff forward? Unfortunately, it's the Cold War. This one is often touted in books as being the first image, television image of the Earth. And that often confused me, but I just realised today when I was thinking about it, that this previous one was probably a secret military image. No one would have been talking about it. This was a weather satellite, not a military one. And then we get to humans in space. Now, this is, I think, a very important difference. We don't have a machine looking at the Earth, we have a human. And this human was very accustomed to taking cameras up on his flights as a pilot and taking photos of sunsets. He loved photography. So what does he do on his Friendship 7 trip? Well, he thinks, I'm going to take a camera. So he went down to the local drugstore, he bought himself a little SLR, he changed the... you know when you have to roll the film around, like the gear train on it? He modified it so that he could use his glove, right? And he took these amazing photos. NASA didn't know about it. But when they saw them, they thought, oh, gee, that's pretty interesting. So, Lunar Orbiter 1, they're already thinking about the moon. They're sending satellites, remote sensors to the moon to view the moon, see what's going on. This is actually the first ever Earthrise image. but it was taken by a machine. But then, can you see the evolution happening here? Can you see? Right? People are seeing this stuff, they're getting it in their imaginations, they're picturing it, they're creating that inner schema. And then finally, we get to that beautiful moment on Apollo 8. There's actually been an automated camera outside the spacecraft taking this image for hours, right? You can see it if you look on Flickr in the magazines, it's there already. But then the guys, the humans, recognise it out the window. And this is what Anders says if you ever want to listen to the audio recording. He says, "Oh my God, look at that picture over there." So this is a picture that has been made for us. It's not just something that popped out of nowhere, it's actually a picture that evolved. My work has evolved too. This was my last attempt trying to make something that engaged your perception, I suppose, in a similar way that that Earthrise image might work, so that you could see yourself looking at yourself. Yeah? See yourself from afar. Because the other lovely thing I like about the Apollo 8 mission and that television broadcast at Christmas is, again, if you were at, say, at home on Earth, looking at the television screen, looking at the Earth being broadcast on the TV, you were actually looking at yourself, which is kind of weird, but a very beautiful thing too. Okay, thank you.
And I love the idea that 1968, 2001, A Space Odyssey is in the theatres. And that's what I meant before about the first to witness, is the human element of witnessing the Apollo witnessing the moon, the Earthrise. Just such an amazing thing to put a human voice on it, human ears, human eyes. And I agree with Colleen about listening to that audio. They sound like children, Christmas Day, "Oh my God," as you would say now, OMG. Imagine in different times the language that would have come out, the swear words perhaps that some people would say. They were so restrained. Our next guest is Dr. Lynette Bettio, Senior Climatologist with the Bureau of Meteorology. Lynette examines and communicates on long-term changes to Australia's climate, including trends in rainfall and temperature, in the interaction with extreme events. Another focus is drought across Australia and how the Bureau can best communicate and inform around this. She's a member of the World Meteorological Organization expert team on drought. As a climatologist, her work draws on data from the satellite system that monitors the changes in our planet's climate. Is there hope, Lynette? We'll find out. A big round of applause for Lynette.
Thank you very much for that introduction. It's great to be here. I try not to be too depressing in my talk, but so I'll try and keep it a little bit upbeat. But there are some challenges out there. So when I was getting ready for this talk, I suppose I really picked up on that. We got that same word, that perspective word. So I think Earthrise has had a profound impact on my field, the field of weather, climate, meteorology, not the least of which was that power of perspective, really seeing that Earth as that one system. So, that weather wasn't just something that happened in your backyard, what happened here that maybe then went on to affect other parts of the globe. Weather happened everywhere. So really allowing us to come together to meet these challenges on a global level. These are global challenges that we had to deal with together. So again, it's a truly global field with organisations such as Alicia mentioned, the World Meteorological Organization, really acting, I suppose, a bit like the Weather Bureau for the whole planet. So examining the weather over the whole planet, the climate, drought over the whole planet. So what happens in Australia, the lessons we learn here, we can learn off what happens in other places, and really looking at that, we're doing that like we do an annual report here. The World Meteorological Organization does an annual report on the planet, on what extreme events might have happened, how many hurricanes might have happened, or tropical cyclones as we call it, and sort of like a health check for the planet every year. So how is it changing, and what's happening? So it's also a community of shared resources with no one country able to do the job by itself. It really is that global challenge. So our job wouldn't be possible with that satellite technology that we see with the technology that has evolved since that Earthrise photo. So at the Bureau, we use the Japanese satellite technology to produce images such as this, and really look at how the weather, so the weather just doesn't happen where we actually have observations to record it, so we can see the weather happening, especially for severe events like tropical cyclones. So we wouldn't be able to do the job that we do today without this sort of technology. So looking at those tropical cyclones, up to the north of Australia, maybe occurring or forming out over the ocean, really looking at how intense they are, how big, how they might impact on Australia, which way they might go. So we wouldn't be able to get that perspective without this technology. So from my point of view, looking at those long-term changes, we're getting to a really exciting point with this technology. So not just looking at the day-to-day weather, which is important, those extreme events, but looking how this has changed over that long period. We're starting to get to that point now where we have a long enough period of satellite records that we can look at the variability and see how this year might compare to a year that happened 20 years ago. Is what we're seeing now outside that envelope of natural variability? Are we seeing these trends? So when I was preparing for this talk, I was thinking to myself, what are some of the images that have had an impact on me? So I thought of this one. This, if you're a student, when I was a student back at the University of Melbourne it was a while ago. This was my screensaver on my computer, and I think we might have even had a poster up of it, and it might have been a few other people as well. We knew it as Hurricane Andrew at the time. We had an Andrew in our group, so he was, a bit excited that, Hurricane Andrew. So Hurricane Andrew was one of the most impactful hurricanes at the time. It was one of the Category 5 hurricanes to impact on Florida, so in 1992. When I went searching for Hurricane Andrew, Google didn't think that this was Hurricane Andrew. It sort of just labelled it as hurricane, but I always thought of it as Hurricane Andrew. So I was studying El Nino events at the time and the impact that this has on Australian rainfall. So you might have heard of El Nino, so you might have heard the term El Nino and then associated with drought over Australia. So an El Nino event we get an El Nino event when there's this warming in the tropical Pacific. The eastern tropical Pacific, way over near South America, impacts on the rainfall that we have over in Australia. So, and it can be as little as a 1 degree of warming, sometimes even 0.5, 0.8, 1 degree of warming of anomaly. So the sea surface temperature anomaly can change by about 1 degree, and we get changes in Australian rainfall. We get droughts over Australia. So I was looking at this, and it's all about that perspective. So you see images of hurricanes on TV, and there's trees flying, and there's wind, and it's a really chaotic seems to be a chaotic system. But then you have this perspective of it from above, and it's organised. These clouds. There's something happening there. It's not chaos. It's an organised, large-scale organisation. And so I was thinking that really, I think, influenced the way I was thinking about my work. So this 1 degree of change way over in the eastern tropical Pacific can actually organise the atmosphere to make these changes over in Australia. So speaking of a 1 degree change, I had to slip a figure in here because I love figures, and I'm a scientist, I love talking about figures. So 1 degree, it doesn't sound like a scary number. I'm going to talk about the changes that we've seen in our climate in the last 50 years. So the title of the session or the evening was Looking Back at Our Planet, but looking back also at our planet, what has happened in that last 50 years. We've seen some changes. What was happening in Australia at the time? So we'd just come out of an El Nino drought in the mid-60s, really similar to what we're seeing now over Eastern Australia in terms of rainfall, or no rainfall as the case may be. We've seen these trends in rainfall over parts of Australia, but one of the big changes that we've seen is in temperature. So this year, what we saw with these really higher temperatures during these drought conditions, we saw an intensification of the drought and really, really impacting on people in Australia. So when I was learning about climate change, well, again, it was a few years ago now, climate change was always something that was going to happen. You know, it's going to happen in the future. It's going to be your grandkids. And this was a scary image for me. It was an impactful image figure because this told me that climate change is happening now. It's affecting my life and it's affecting the lives of people around me. So what is this figure actually telling us? So what happens, so if we got all the people in the room here and line them up shortest to tallest, so we'd have some short people here, we'd have some tall people up the end here, and most people like me would be around average. So we'd have most people in the middle here. Most of the audience here are old enough to remember phone books. So we got the big Melbourne phone book and everyone stood up. I'm not going to make you stand up, but everyone stood up and we stood on that Melbourne phone book. We'd now have more taller people and less short people than we did before. So we'd have more people up this end, more of those taller people and less of those shorter people. So that's what we're seeing with our temperatures. That 1 degree, that small number, is actually making a huge change in what we see at the extremes, at the edge of that line, that row. So very warm, and if you read ahead, very warm monthly daytime temperatures that occurred just over 2% of the time during the period 1951 to 1980 now occur over 11% of the time for the period 2001 to 2015. So just that 1 degree shift, we've seen a 5-fold increase in the number of those extreme warm months. So we've also seen this on for the daily heat extremes as well. So again, daily heat extremes are one of the most impactful natural disasters over Australia. More people have died in heat events than in any other natural disaster. So really impacting on our lives. So what we've seen is it's something that we have to adapt to. We have seen these changes and we have to adapt to this level of change. So in 2009, in the heatwave leading up to the tragic Black Saturday, 374 people lost their lives in the heatwave leading up to Black Saturday. And that set across a lot of changes, a lot of adaptation needed to, is this going to happen again? Is it going to happen more frequently? And it's going to have to be something that we're going to have to deal with. So the Victoria put in a heat health plan, and in the subsequent heat wave in 2014, in January 2014, this heat health plan was credited with reducing the mortality associated with that event. 167 people still died in that event. So again, it's that we do have to adapt to some level of change. I've signed up I get the alerts for the area that my parents live in. So I can call them up and, yes, Mum, you have to put the air conditioner on now. So just to keep track. So it's at this point that I usually stop my presentation and people just look at me a little bit shell-shocked sometimes. So I thought I would, and then in the questions, any questions, and they say to me, one of the questions I get sometimes is, how do I keep up hope? I'm a pretty optimistic person, and But, and I will admit, it is a challenge. There's challenges out there, and it's going to take a big effort, a big global effort to meet those challenges. But I think you feel hopeless in the absence of change, and I've seen a lot of changes happening, especially in the last 2 years, this growing global awareness, and again, this awareness that we have to meet it as a globe for the challenge. So I thought I'd share this last image with you. So again, when I was preparing for this talk, I came across this article and I thought, wow, this really fits in really well with this talk. Not only is it a beautiful photo, at first I thought, oh, where are all the figures? But there, it's a lovely photo with the colours actually showing the levels of ozone, with the redder colours showing more ozone. So the ozone hole could have been a big one this year, but it wasn't. Those global efforts to reduce atmospheric chlorine are paying off. So I just thought, wow, this is just a beautiful image to illustrate that, and what an encouraging headline. So in finishing up, we need to use the power of images such as Earthrise, such as this, and this global effort. And the changes that we've seen, all the work that we've done over the last 50 years, really to choose our path that we're going to take for the next 50 years. So I'll end it there. Thank you.
I'm glad there's hope. I've always loved that William Carlos Williams poem, The Red Wheelbarrow, that says, so much depends upon a red wheelbarrow glazed with rainwater beside the white chickens. Most people say, what? But to me, it is about powerful images, like Lynette showed, that sometimes you see an image of, say, a Jack Russell on a dead farmer somewhere in Africa that won't leave his owner's body for days and days. That's a powerful story, or something akin to what Lynette showed us, that images are so powerful, as Colleen said as well. Our last speaker, Dr. Jenny Gray, CEO of Zoos Victoria and the President of the World Association of Zoos and Aquariums. Jenny is a trained civil engineer with experience in transportation, engineering and banking. But it was a lifelong love of animals and a longing to do something that made a difference, which brought her to the zoo industry. Jenny's work as CEO of Zoos Victoria has significantly changed the organisation's direction to engage people in saving wildlife and wild places. Her Melbourne PhD examined the ethical challenges posed for the operations of zoos and aquariums in the 21st century, and her thesis informed her 2017 book, Zoo Ethics. A big round of applause for Dr. Jenny Gray.
Thank you so much, and thank you for the introduction. I prefer the title President of the World, full stop. And what a joy to be talking about this incredible image and what it means to all of us. This moment when we saw this image. And I'll bring you back, as everyone has, to 1968. And who knows what the #1 hit parade song was for 1968? Come on, you can have a good guess at who the band was. Yeah, really good. Everyone gets that one right, but which song was it? Hey Jude. And so while Paul McCartney asked us to take a sad song and make it better, astronauts circumnavigated the moon and took this picture that showed us just how fragile and beautiful this tiny planet is we live on. And so what did we do to that sad song? Well, they started up a couple of things, and they got on with making life for people better on this planet. If you look across those 6 indicators, it's a terrible slide, I know, but the dotted line is 1968, and the graphs you can see all go in the right direction. We started tackling extreme poverty, basic education, literacy, democracy, vaccination, and child mortality. We made it better for humans, and one graph went in the other direction. We doubled the number of humans on the planet from 1968 till now, in 50 years. And what that meant was there was no space left for animals. We've taken every square inch we can and we've covered it with our city. We've covered it with the areas we need to make food, whether we're subsistence farmers or large-scale farming. And it's never more stark than when you actually fly over the top of a protected area. And you see the difference from what the land used to be into what it is now. And you realize that all we've left behind are mountains and swamps. I have a friend who works at the World Association of Zoos and Aquariums who says he's afraid of flying, not because he's afraid of the aeroplane, because when he looks out the window, he can see what we've done to the planet. And so not surprisingly, the number one threat to animals on this planet is habitat loss, because we're taking that space for ourselves and the animals we need. And we destroy habitat just to make cheap oil so that we can put it into our food. The second worst problem is the pests that we've introduced and spread around the planet. And I can't think of a more fitting villain than our very own cane toads. And then we talked about bushfire. We work with 3 species that are literally one bushfire away from extinction. A fire in the wrong gully, a fire in the wrong stand of trees, and we're going to lose those species forever. And finally, we're filling our ocean with junk, with plastic that we don't need, and we're not thinking about what we're doing. And so unsurprisingly, the IUCN lists over a third of animals as critically endangered and threatened. Only last month, WWF put out a report that showed across species we've seen a 60% decline in the number of animals in species. And so what has changed? Well, zoos have changed since 1968. What have we been doing? We've moved away from these traditional horrible enclosures into habitats where animals can live a better life. We've got them off the concrete and out living in open range settings where they can be what they were designed to be. We've stopped having animals reared by humans just as something curious to touch and let their parents rear them. Maybe not always a good thing, but we know that they're experiencing a life and it's up to us to make sure that those are good lives. What has also changed is our understanding of animals and what it means to live a good life. And this is only since 1985, and the number of studies into animal welfare is following the trajectory of the human population. We've learned so much about these smart, incredible creatures we share a planet with. And anything you think you know right now, you're wrong. You're going to learn more in the next 50 years. We've learned about genetics and molecular basis. And for each and every animal, we learn incredible secrets about how they breed and reproduce. And for this species, what hasn't changed is our fascination with all things animals. And the number of people visiting zoos has skyrocketed. We just are so intrigued by every aspect of them that we get caught into the wonder of what it is to look into the eye of a giraffe and see yourself reflected in it. We might have changed the way that we experience that because we need to capture our own image in that. And what also hasn't changed is the fascination and the impact we have on rich people and people of influence. Here is Robert Kennedy visiting the Bronx Zoo in 1968, and here's Prince Harry and Meghan Markle visiting Taronga Zoo just last month. They still come out. And we have this incredible reach where we can reach not only the everyday people who visit our zoos, but we can also reach the rich and famous. And social media has changed the ability to reach people at an extraordinary rate. And so we can spread around the world messages of change, of things that we can, each and every one of us can do. We can get that out in a click of a button. And just as quickly, we can hear stories of terrible conditions where animals live in substandard zoos. And this leaves us all asking the question, what are we going to do? What are we going to do with the next 50 years so that when they look back at us at this time, they know we've done something good? At Zoos Victoria, we've changed. We have a vision that we want to live in a future rich in wildlife. And we've committed that we will not let any animals go extinct on our watch. No Victorian terrestrial vertebrate species will go extinct on our watch. That's quite a tongue twister. I say it often, so I don't fall over too badly on it. One of my staff did say no extraterrestrial vertebrate species. So again, I'm putting it out to all of you science people. You find one, call me, because we are certainly helping with that. But what does that even mean? Well, here's what it means. It means there's 21 species here in Victoria and right next door in our neighbours that if we did nothing would go extinct in the next 5 years. Some of the animals on this list we're down to as few as 50 or 60 left in the wild. One of them is currently listed as extinct and one we haven't seen for 48 years. And if we don't find one soon, we're going to have to say we didn't make it right. The grassland earless dragon up in the middle there is that one, and it's only found in Canberra, where it's actually an advantage to have no ears. And if you guys are slow, but if they gave me more than 10 minutes, I could run through and tell you a story of each and every one, but instead I've got it down to 3. The orange-bellied parrot, another tongue twister. Of these, there's only 50 left in the wild. We are working on a program where we breed them. Last year, we released 35 back into the wild. We don't know what's causing the loss, but what we do know is this little crazy bird is tiny, migrates from Tasmania to Victoria every year across the ocean. And what we have found is very few of them get back there at the end of winter. And so we've been helping them with what we're calling assisted migration by Jetstar. And I was delighted this season, after we'd moved the ones that we'd been working with back, one of the wild ones showed up at Werribee and sat on top of the aviary like he'd heard. There's a better way to get back to Tasmania. This is an eastern barred bandicoot. At one stage, they ranged right across Victoria. They evolved in a time when we only had aerial predation, and their entire defense mechanism involves sitting in a bush and not moving. Great when you've got aerial predation, terrible when someone brings cats and foxes along. And so they're currently listed as extinct in the wild in Victoria. We're working with some incredible partners. We're now up to 2 freestanding populations, and over the course of the next 18 months, we'll get our third freestanding wild population with an aim of 2,500 animals back in the wild. It will be the first mammal recovery in Australia, right here in Victoria. And it's a great way to raise funds, because you say to government entities, we're recovering a species. Do you want to be with us on the podium when we launch that? Most of them do. And then these guys, Lord Howe Island stick insects. They were thought extinct for a number of years until they were found on Ball's Pyramid. Because we have a butterfly house, they brought them back to Melbourne Zoo, where our guys stayed up all night keeping them alive. They laid eggs. We're now at a point where we have 500 adults and 15,000 eggs at any given time. And we're working with the community in Lord Howe Island on how we bring them back to the island. And so it can be done. What we did for humans, we can do for animals, but we only do it when we work together. And so our future is in how we work with the 2.5 million people who come through our gates to turn them into conservation champions, to make sure they care as much as we do, and to make sure that they are passionate about the future of animals. Because when we all declare our love for animals, we then stop and think about the actions we take every day. We think about whether we buy food that contains palm oil that leads to the destruction of habitat. We think about what we do with the animals that live with us. We think about keeping our cats in at night because it's better for wildlife and it's actually better for our cats as well. We can all make a difference. I get letters. They send me pictures. Now, okay, luckily his mom wrote this as a lion. And if you're laughing now, you should see the hippo. It's even more challenging. And I, just because you're 3, I think we should point out that lions have 4 legs. I think it's a simple lesson. But this little guy loves lions. He loves them enough to draw a picture of a lion and send it in to me. He's 3. When he's 53, will he be able to see lions in the wild? Will he be able to do what we do and take lions for granted? There's only one little round ball like this, and I know you're looking for another one, but it's pretty special. And the creatures that are on this journey with us are absolutely amazing and special as well. And it's up to each and every one of us to take the decisions and the actions that will make sure this planet carries on journeying full of diverse wildlife. Thank you very much.
It's amazing to hear such hope. We only have a short amount of time, and I could hog asking so many questions. But as you're giving a round of applause to all of our speakers, maybe come up and... So I'll ask a question of all of you just for a short answer. I know that's hard. So how do we solve everything? No. In the next 50 years, in your fields, what image would make you happy? Rachel, what would make you personally happy to see?
Image.
Yeah, an image. So would it have been a discovery or something of that ilk?
Well, I think probably the thing that I ended up on, which is finding life off the planet, just because life is extremely precious, but I guess as an astronomer, I probably think there's life elsewhere in the universe, and to understand that will greatly evolve our understanding of the world we live in.
Oh, and what form would that picture take?
I have no idea. But it probably won't have 2 legs and 2 eyes.
Little green men.
I don't think so.
No. Thank you, Colleen.
I'd probably like to see a picture taken by someone on Mars. Mm-hmm. And again, I'm going to bring that back to the human, because I know it's probably quite, it is these days quite easy to send robots to Mars, but the poignancy behind that Earthrise image is the fact that there was someone there, someone doing the looking through the lens. So if we go to Mars, I would really like to see some happy snaps.
I think that might happen in our children's lifetime, maybe. Fantastic. Lynette?
I was going to cheat and say a figure.
No, that's good.
So I talked about 1.5 degree of warming, so that's our aspirational target. And I'd really love to see the graph in 50 years that we stayed below that aspirational target. And then I was thinking, well, I'd love to see the picture that my kids are taking. They're out playing on a beach somewhere or out enjoying nature, and all the things that we take for granted now, that they're still able to be out taking photos of those times.
Pictures of the barrier reef still thriving.
Maybe.
That would be good. Thank you.
I was going to say what Lynette said. I would like to see her graph, but that the next one goes back the other direction. And then the other picture I would love to see is a captive-born Leadbeater possum. It's our faunal emblem. They're critically endangered. If we continue to cut down the forests they live in, one day they will only live in captivity. And you think it's easy to breed animals in a zoo. There's nothing that's critically endangered because it's easy. All of them are really tricky, and we haven't cracked that code yet. And so if we lose them in the wild, we will lose them forever. And they're remarkable little creatures.
And I'd like to see more of those drawings of lions.
Yes.
You're welcome anytime. You can write back as well.
It's funny how an image like that can tear you up, that a 3-year-old is so interested in the world, and that's so full of hope. So I'll open it up to you. We haven't got much time before we go downstairs for supper. So, yep.
Hello? I just want more national parks, especially the Great Forest National Park.
Yes. Comments are welcome too.
I'm just curious, if this photograph has had such an effect on humanity over the last 50 years, then why do we keep voting for people who say that coal is good for humanity?
Climate, how can there be climate deniers with the science and the graphs and pictures and studies? How does it happen?
They didn't do physics at school.
I think as a scientist, we started, early on, oh, you don't believe so? Oh, here you go, here's some more information. Oh, here's another graph that shows you what's happening. And we realised that actually doesn't work. You can't just show people more information and expect them to understand what you're trying to tell them. So I think that's where all these different disciplines and coming together is so important, having these images that can speak to people in another way rather than just, adding 2 numbers together.
It was interesting, I thought, what you said in your introduction, and you showed that lovely image of the atmosphere with the new moon. And a lot of astronauts, in fact, almost all of them, comment on how slim that atmosphere is. I mean, I'm sure it feels very different when you're going in and out of it in a rocket, but when they actually get to see how tiny it is, that's another moment that they all say, you know, like it's so fragile and so small. It's just like, you know, cracking an egg.
And the evocativeness of art. And animals have that power to speak to people, don't they? As in, people care about what animals go through, I hope. Another question? Sorry, we're racing through. Up the back and then...
Thank you. Thank you to all of you. What a wonderful series of papers and discussions. I have a kind of parallel artistic comment to make in relation to the Earthrise photo, and that is that during this time, of course, what's also going on is David Bowie singing. Yes. And David Bowie singing Space Oddity. And something that maybe David Bowie picked up on in relation to Earthrise and space exploration is the importance of diversity. Diversity of different people, representations, different selves, and ideas of what the Earth could be. And so I'm wondering if the panel generally, and perhaps this is something that cuts across the panel, is the importance of diversity to thinking about ways to save the Earth, both ecologically, socially, politically and culturally. What do you have to say about that?
I'm happy to have a go. I think it's so important because once we stop othering, once we stop thinking of ourselves as just being the most important group and we start conceding that there are others and that they have diverse views, we also start to concede that there are other life forms and they're also important. And so, yes, I think it's an incredible first step is when we start to realise there are others and that they bring enormous value.
And yes, I absolutely agree that diversity is also the key to understanding that we are actually one planet. Like, they go hand in hand. You know, they're the two sides of one coin, really. And recently I went to see First Man, that fabulous film that's out now. And of course they did a great scene where they pointed out that the space program was so white. You know, it was so, it was American, it was white, it was male, it was the absolute opposite end of anything that was diverse. But it is now. I mean, NASA is an organisation that has changed a lot since 1968. Sometimes for good, sometimes for bad. It's a very big beast. But, you know, astronauts from all walks now. So that is one good thing. And again, it's that image that points out that, you know, the Earth might be made up of all these different people and all these different places and ecosystems and climates, but it is one. And so all those diverse factions need to work together.
I think the thing I'd like to add in is that in the current state that we're in the world, the current rate of change, it's actually the decision makers and the rapidity with which decisions are going to have to be made that is critical. Yeah. And at the moment we have almost no diversity in those decision-making entities, people. And I really believe that the only way we're going to get a significant change is by diversifying our decision makers.
Great points, yes.
I just wanted to say thank you again for the presentations and also this moment. I've got so many questions, I don't even know where to start. The overview effect, that effect that's described by the astronauts when they realise that that's it and it's all in there, could we package all of the leaders up, send them on a spaceship, give them the overview effect and not let them back?
I thought you were going to say leave them.
Yeah. No, I think there's a real story. Yeah, what I love is the diversity that's represented at the table, and we need a new meta-narrative that isn't that this planet is here for us and our exploitation, but that we are indeed animals. We do indeed live in that space. And I was saying to Mike earlier, I just read Brian Cox's Human Universe, and if you haven't read it, you should. it puts us into the world, and as soon as you realise that, you realise how precious it is, it changes the fundamental way that you think. So I think that the diversity of art and astrophysics and climate science and zoology is core to that thinking. Can we send everyone to space?
You'll have to ask Elon Musk.
It's an expensive. Yeah.
Hey?
I was going to say, one of my favourite jokes has always been, if you can put one man on the moon, why don't you put them all there?
Is there a plan B for Earth?
Thank you for a most engaging series of discussions. One point I'd correct. NASA may have appeared white and uniform, but there was a diverse culture, principally women,
Yes.
of many races who supported that program but are just not recognised or weren't at the time. But more importantly, there was mention of changing the diversity of our leadership in order to get greater understanding and traction in the area of climate change. Perhaps what we actually need to do is diversify the way we put the story to them. So we've done a lot with figures and graphs and sciencey talk. Perhaps we need to tell a story that is more engaging. And for this, I'd refer to somebody like Bernard Salt, one of our demographers, who's actually very good at taking numbers and statistics and the economics of this sort of problem and actually painting a story of what it's going to mean. We need to find a better way to articulate the problem. So the responsibility is not just with the leaders, it's within our own leadership in the area of and field of science and art that we actually put this more effectively.
A good comment, yes. We've only got time for one more question, then we'll go for supper and we can mix and talk, and we could talk to these women for hours. Yes, last question.
So if Earth no longer becomes available for life on it and we have to move to another planet, what would happen to all the animals? Like, if we were to take them over, what about migration? Because they would be used to continents and other things around that, and they would be trying to fly to certain areas that aren't even there. Like, what would happen to migration and the habitats?
Jenny, if all the humans were gone, what animal would be on the top of the pyramid?
That's a different question, and E.O. Wilson has a great quote where he says, if all the humans left, the planet would do quite well. But if all the insects left, the environment would collapse. And we're all less important than insects. And so the important question you're asking is, if we did build a spaceship to head, and hopefully you found us planet 2.0 to go to, who would we take with us? And how would they do? And that's really a tough question, because so much would depend on what that environment would be like. As you're saying, there's so many things you have to think about. The chances are we would take dogs and cats and pigs and cows and animals we can eat on the way. And that would be a tragedy, but we would probably do that first. But I think
Why
you're right.
did you start with dogs and cats on the menu then?
Sorry, Emma. But we would look at, I think it would be a great question, and I don't have an easy answer, because I think it's a great philosophic question. Who would you take on this journey? Which animals would we miss the most? And that's also just missing the point that each one of us is a whole galaxy of microorganisms, and we're not just some creature on our own. Each of us is one of those little galaxies. And so if we think we can live without our environment on Earth 2.0, I think we've got a rude awakening coming there as well.
Did you want to? No, that's a great way to end this session. I want you to join me in thanking Dr. Jenny Gray, Dr. Lynette Bettio, Dr. Colleen Boyle, and Dr. Rachel Webster. I could listen to each of them for a long time. Just quickly before you go, we have Kevin Allman Rossiter for the vote of thanks, and thanks so much for listening to us. Come on up, Kevin.
I think you've said all the great words, but there are two words that I think I heard quite often tonight. One is impact, and the impact of a very simple thing like the picture of Earthrise, both in the immediate time. I'm a little bit younger than David Zerman, but I still grew up in the Apollo era. And after discovering that being 6 years old and not American meant that I really couldn't become an astronaut, I instead did physics. So there's an immediate impact, which I think many of us would have on what is immediate. But I think the perspectives that we heard from all of the speakers is fantastic, because 50 years on, the impact is still there. And so when people ask us, what's the impact of this bit of science or this thing, sometimes that's a difficult question to answer, and one that you shouldn't spring immediately to mind, because there is an immediate impact, but there's also something that we can discover 50 years on. So I'd again like to thank all of our panellists for perspectives of 50 years on after something that's a very simple picture of Earthrise.